calibration. In our lab, we're going to be calibrating a current to pressure transducer. We're going to be using some math. So for this math to make any sense, we're going to have to learn some definitions. So first of all, we have our process range. So our process is going to be between 3 and 15 psi, right? So this is our lower range value. That would be this right here, lower range value. Here's our upper range value. It only matters for one thing, so that we could tell the difference between the two. The difference between the two is our range. What's our range? 12, because between 3 and 15, there are 12 psi. So lower range value and our range. We're going to use that in our formula. Also, we're going to need to know 3 more definitions. It's instrument, signal, zero, and span. Specifically, instrument, signal, zero, and span. Well, the zero, of course, is the lowest value of output from the instrument. But the only reason we need to know this zero now is for the offset. The offset is the value to which zero is set. So this is our offset. Why? Because in our lab, it's going to be a 4 to 20 milliamp signal. So here we go. Our offset is 4. We're going to need to assign a value to that offset. We're going to need the math for that, or the numbers for that. So, okay, now we also need to know what a span is. So the span is the difference for our instrument. The span is the difference between the lowest and highest output value. Why? Well, you're going to see that when I go to calibrate this transducer, I'm going to give it the 4 milliamps, which is the lowest signal it's going to see. And I'm going to adjust my 0 to 3 at 4 milliamps. So I want to see 3 psi output at 4 milliamps. So the offset, the value to which I set my 0, and the instrument 0 is that knob or that potentiometer that I adjust so that I could get 3 psi of 4 milliamps. So then the instrument span, when we give it the 20 milliamp signal, when we adjust the span on the instrument, we want to see 15 psi out. You're going to see in the other video that when I adjust the span, I'm adjusting this. And you're going to see that we go back and forth between the 2, 0, and span so that we can calibrate it. Because every time we adjust the span, we do this. Every time we adjust the 0, we're doing that. So you can see that one will adjust the other. So we're going to go back and forth for calibration. So on our signal side, the span is going to be the difference between the lowest and highest numbers in the control system. That's what we're talking about here. Not the instrument span, but the span of our signal. So here we go. What's our span of our signal? This would be the span. Our span is 16 milliamps, because between 20 milliamps and 4 milliamps, we have 16 milliamps. So just so we understand what we're looking for here, the span here would be the 16 milliamps here, right? So we've got lower range value, range, offset of 4, and span. And then these values will be given, or sorry, these are the values we'll be looking for when these values are given. So let's just do a couple of examples right here. Let's just say that we have 6 psi. At 6 psi, what kind of a signal could we expect to have at 6 psi? Well, let's just do the math here. So we have 6 psi minus 3, right, over our range of 12 times 16 plus 4. Don't do this thing where you add these two numbers together. Remember BEDMAS, please. Well, what's our answer here? We'll have 8 milliamps. Remember, what we're doing is we're adjusting this here. We're going to have that there, and then we're going to come up to here. So we're going to be, should be a straight line between these two. That's a lovely straight line I just drew. So we're saying that at 6, I should be at about 8 milliamps. Well, look at that. 8 milliamps should give us 6 psi. That makes sense. Let's do another equation. Let's just say that we're sitting at 10 psi. All right, 10 psi. Let's do it again. Minus our lower range value of 3 divided by our range of 12 plus 6, or sorry, times 16 plus 4 should give us about 13.33 milliamps, right? So going back this way, if we're at about 10, should be about here. That all looking pretty good. So at 10 psi, we should be at about 13.33 milliamps. Right there. Okay, so let's just go the other way now using the other formula. If we're looking for a process variable, but we have a signal. So let's just say our signal is 12. If we're here, let's do the math back this way. So if our signal is 12, what's our PV? So if our signal is 12 and our offset is 4, well, we're going to divide that by our span, which is 16, right? Times our range, which is 12, plus our lower range value, which is 3. That gives us 9 psi right there. So that makes sense. Look at that. That lines up very, very well right there. Okay, and let's do another example. Last one that we're going to do here. Let's just say we are looking for a process variable, and we have 14.7 milliamps. Okay, so what are we going to do again? Subtract our offset and then divide it by our span, multiply that by our range, and add our lower range value. What do we get? We get 11.025 psi. So here we are somewhere around there at somewhere around here. So you can see this math works both ways. We can go either way this works, if it's an I to P or a P to I or a P to V. So we can have milliamps as a signal, or volts DC, 1 to 5 volts DC. You might see 0 to 5 volts DC. In any case, the math works out the same. And for you to do this math, you need to understand where to plug the numbers. Okay, so good luck with that, guys. I'll be posting some assignments, practice assignments on Slate to check your knowledge. I'll give you some word problems that are very similar to what you might see in a test or a lab, so you could practice and check your knowledge.